Hi, once again, welcome back to our video. So here's another example. Let us determine the particular solution of the given DE. So we have x cosine squared of x over y minus y dx plus x dy is equal to 0 when, so this is our initial condition, x is equal to 1 and y is equal to pi over 4. So we have here once again equation the function of m, x, y, and the function of n. Okay. The equation cannot we cannot use separation of variables to solve this kind of problem because we cannot simply separate x and y variables. So let us check if this equation has a homogeneous coefficients by placing the lambda. So we have lambda x cosine squared lambda y over lambda x minus lambda y. So we can cancel out lambda and we can factor out the lambda here. So we have lambda, then our function x cosine squared y all over x minus y. Okay, so this is at degree 1 as well as this. Okay, so this this given differential equation is a homogeneous of degree 1 in x and y. Okay, so after that we will let the substitution like what I have said. That we can use either w is equal to y over x or w is equal to x over y. Okay, so if we use this, we have y is equal to wx, and for this one we have x is equal to wy by doing the algebra, then getting its derivative. We have first times derivative of the second plus the second times derivative of the first, as well as this one we have first times derivative of the second plus the second times derivative of the first. Okay, but if we have a problem like this, you need to first analyze which substitution is much easier to use, or which substitution might lead our differential equation into a separable equation in a easiest way. Okay, because this when you try this substitution A and this substitution B, then you might lead to the same answer, but the solution is different. So you need to first choose which substitution might have a easier way or easiest path to solve our differential equation. Okay, so this time let us analyze first if we will use this substitution. Then since we have y and dy, so our substitution here is y, we have wx. So this x cosine squared y over x will now become y is w over x, so we can cancel out x, so we have cosine squared w minus our this part, and then we will substitute dy by this part, which is also easier to simplify because we have only a simpler term here. So this substitution is applicable, or say we can lead to a simple path to solve our differential equation. So for this substitution naman, so let's analyze first. If we will let w is equal to x over y, or x is equal to wy, so we will change this as well as this x part here, and we might end up with, since we have wy, we might end up with 1 over w here, so which is equal to w raised to negative 1, which is much difficult than this one. Okay, what else? Yeah, so this substitution of w is equal to x over y is much difficult than the substitution of the w is equal to y over x. So for this specific problem, let's try to use this part because syempre we want the easiest way. Okay, but of course if you want to check and to double check your answer, you can also try both substitution. Okay, so if we will use this, our equation will become x cosine squared y is wx all over x, then minus y is wx, then our dx plus x, and then our dy is this one, w dx plus x dw. So by the way, this is first times derivative of the second plus the second times derivative of the first. Okay, so always double check your substitution. This is equal to 0, right? Okay, so after the substitution, let us now simplify. We have x cosine square w minus wx dx plus xw dx plus x squared dw is equal to 0. So we have here, okay, x cosine square w dx minus wx dx plus xw dx plus x squared is equal to 0. And once again, as you can see here, we have xw dx, we have xw dx, we have negative positive, so we can cancel this out, and we've left with these two terms. Have x cosine squared dx plus x squared dw is equal to 0, So we need to separate x from w. So we have x here, dx here. So we need to divide this by cosine squared w. And since we've divided this by cosine squared w, we need also to divide this by same term. And since we have dw here, so we need to cancel this. So let's divide this by x squared. Since we've divided this by x squared, we need also to do the same on the other side. So let's now proceed to the cancellation. We can cancel out this and cancel out x squared. So we have we can also cancel this out. We have dx all over x plus dw all over cosine squared w is equal to 0. Then our next step is to integrate both sides. Integral of this is just ln of x. And how about this part? We can use the trigonometric identity. 1 over cosine squared w is just equal to secant square w dw. So we have ln of x plus the integral of this is just tangent w, and of course our plus c. So we need to bring back the value of our w, which is y over x. So we have ln of x plus tangent y over x is equal to c. So this is now our general solution, but our task is to find the particular solution given the initial condition x is equal to 1, y is equal to pi over 4. X is equal to 1, y is equal to pi over 4. So let's substitute the value of our x and y. We have ln of 1 is equal, plus tangent y is pi over 4 all over 1, then c. So we have our this ln of 1 here is equal to 0. So our c is just equal to tangent pi over 4. And we need to substitute the value of c. So our general solution to find the particular solution. So we have ln of x plus tangent y over x is equal to our c is tangent pi over 4. So this is now our particular solution. Okay, by the way, if you gotta check this tangent pi over 4, this is equal to 1. So our c is equal to 1. Then our c here can be right as equal to 1. So this can also be our particular solution. Okay.